Hello, we're Team 14. My name is Garcia.
Hi, I'm Saad.
Hi, I'm Prajeepkumar Nair.
And we're going to talk to you about our gearbox design. So right now I'm going to talk to you about the history. Gears are considered as one of the oldest pieces of equipment known to mankind. The Chinese south-pointing chair was invented in the 27th century BC. Bevel gears. Bevel gears are where the axes of the two shafts intersect. The tooth-bearing faces of the gears are conically shaped and are most often mounted on shafts that are 90 degrees apart. Example of bevel gear systems. As you can see here, they're on differential systems on automobiles and also on electric hand drills. Our problem statement. We were given 3.5 horsepower transmitted to our system along with a 660 and 30 value for our input and output shafts with an opposite direction. So the objectives of this experiment was the bevel gears are used for perpendicular shafts in the same plane. That velocity ratio gave us 660 over 30, which was 22 over 1, and the train value was 0.04545. The analysis. We had to use 4 straight bevel gear systems in this design. So we had a 1:4, 1:4, 1:4, and 3:1 ratio, which is 3 over 64, which then became 0.046875. As you can see, that value is close to our target value right here of 0.04545. That means our system had 3 step downs and 1 step up. So we had to change the numbers a bit in order to get close to our target value. Calculations. We had a pressure angle of 20 degrees and the bore diameter was given to us through the catalog. That means that our teeth was also given to us with 15 teeth for the pinion, 60 for the gear, 20 for the pinion, and 60 for this gear on the second system. Alternative designs. We had 3 systems. The most accurate one was system 3, which was 1:3, 1:3, 1:5, and 2:1 ratio. That came to 0.0444. So I was close to our target value here of 0.04545.
As you can see here, guys, when we designed our gear system in SolidWorks, this is what we got, and this is how our gear system looks like. Here we have gear analysis for bending. And here we have gear analysis and different parameters used for calculating wear stress, and also the objective of this is to get a safety factor that is above 1. Here we have the shaft analysis, and as you can see, we use the DE Soderberg method to calculate the life of the shafts. We have the bearing analysis, we have the C10 load catalog factor, and over here these formulas we use to calculate the length of the keys and pins used in the gear system. Quick schematic of our gear system. Here we have the input going laterally in XY plane, and the output here is in XZ plane, coming outwards from the page. Here's our calculated data for gears. As you can see, like you noticed, SH and SF signify the safety factors for wear and bending respectively, and they're all above 1, which is a good sign for our system. And now we have, for the pinion, all the SH and SF values are above 1, which is again a good sign for our system. That means our system is safe. Furthermore, we have a few shaft analysis, bearing analysis, and key and pin.
Hi, this is the cost estimate that we use in our entire design. We use the gear ratio 1:4 for 3 pinion and 3 gears, and 1:3 ratio for 1 gear and one pinion. And also we use the ball bearing from the Timken catalog S7K, and we use 8 bearings in total design. And also we use the shaft and the square key from the Boston Gear catalog system. And also we use the machined gearbox for our entire design, and the total cost approximately is about $1,880.47 for the entire gearbox design. The maintenance for the gearbox system. The effective lubrication is one of the important features to all gearboxes, and will help prevent the gear and bearings from failure. And also you can see the vibration is another key important diagnosis of the machine fault. The troubleshooting is a significant component of a comprehensive preventive maintenance program. And other important surveys include the vibration and oil analysis. Application. The application of bevel gear is widely used in many industry, especially marine application, the power transmission of rudder and the propulsion system. The bevel gear is using. And also you can see in the aviation industry widely using for the landing gears and the flap at the time of landing of airplane. The conclusion. After thorough analysis, we have accomplished to design an effective system that resists bending and wear with an acceptable factor of safety. We learned designing a gearbox is very complex, as if a single value changes in the system, it affects other component value. And also we would use the other types of gear that just bevel gears and different material to understand how it would affect the system. This is a small video of our presentation. We use 3 step-down gears and 1 step-up gears in their entire design. That's all our presentation. Thank you for joining us. Thank you.